Next we see the topic of Einstein explanation of photoelectric equation. So we know the properties of photon. Photon having the energy is h nu. So energy h nu of the photon is instant on the metal. This energy is absorbed by the electron in the metal and this electron is ejected. So our instant photon having the energy h nu is used in the two ways. Some part energy is used as the work function and another part is used as the kinetic energy of the ejected electron. Kinetic energy of the ejected electron. Here pi naught work function is nothing but a minimum amount of energy required to liberate the electron from the metal surface. Okay. From the property of photon we know that during the collision total energy should be conserved. So from the law of conservation of energy we can write h nu is equal to pi naught plus half mv square. Pi naught plus half mv square. Here m is the mass of the electron, v is the velocity. Next, if suppose we are decreasing the frequency of the instant radiation, the speed and kinetic energy of the photoelectron also should be reduced. If suppose we are exposing the light with the frequency nu naught, the ejected photon having the almost zero kinetic energy. Okay. So kinetic energy will become 0. So this equation can be right h nu naught is equal to pi naught plus 0. So h nu naught will be equal to pi naught. When we exposing the light with the frequency nu naught, ejected electron having the zero kinetic energy. So we can write h nu naught is equal to pi naught. So in this equation can be right h nu is equal to h nu naught plus half mv square. This is a Einstein photoelectric equation. During the collision, if the electron does not, there is no energy loss during the collision, so ejected electron having the maximum kinetic energy. That means during the interaction inside the metal, there is no loss of energy. Means ejected electron having the maximum kinetic energy as the k maximum. So kinetic energy is equal to k maximum. So v is the maximum velocity of the ejected electron. So we can write h nu is equal to pi naught plus k maximum. From this k maximum is equal to h nu minus pi naught. From this we can draw the graph. We can give the relation between the kinetic energy and frequency. When we draw the graph between the frequency and kinetic energy, we are getting the straight line. Below this certain frequency of the nu naught, there is no emission of electron. Above this frequency, as the frequency increases, ejected electron kinetic energy also will be increases. The slope of this graph will be, we are getting as the h. That means y-axis divided by x-axis. Y-axis la we are getting h nu by nu. So nu get cancel, we are getting h. Suppose for this, now we are getting h nu naught by nu naught. Nu naught, d naught get cancel. So we are getting as a slope as the h. And also it intercept is negative work function. So Einstein equation was experimentally verified by the R.A. Millikan. He draw the graph between the same one, kinetic energy and frequency. And also he found, the R.A. Millikan found that slope is independent of the metal. We are getting as a h, that is independent of the metal. That means h is the constant. So from this Millikan also found the value of Planck constant h is the 6.626 × 10 - 34 joule second. This is slope. This is for calcium. And if you take slope, this for sodium, potassium and cesium. For each and every metal, the slope will be h. It is calculated as a constant value, 6.626 into 10 power minus 34 joule second. And the work function of this metal will be same as that of the theoretical value. So this value or function of this metal, that means cesium, potassium, sodium and calcium, these values are agree with the theoretical value. These are all about the Einstein photoelectric equation.